Okay, welcome everyone. So today we're gonna talk about some examples from chapter 14. So I guess we're going to learn this chapter in 2 weeks. So this week I'm gonna talk the first 3 examples from this chapter. Then next week, Haifeng and Robin gonna share more of the other 3 examples. So this example is mainly to show us how we can load different types of data and also what kind of EDA we're going to do. And of course, there are some data visualizations, and we'll also learn how to use some of the pandas to do some of the EDA work. So if you can follow along this example, so the notebook is shared in this Git repository, and the data sets you can download from the GitHub link that I have sent out. So if you download this data set and save this data set in the same working directory with your notebook, then when we run the examples, then they can recognize the data sets. So without further ado, we can start looking at these codes. So first of all, the first example is from the U.S. government data, which is mainly about how different regions they use the operation system of the computers. First of all, we'll import the random to generate some random numbers from NumPy, and we'll set this random seed. Usually you'll set a specific seed, so every time we run the code, you'll have the same results. Otherwise, you'll get different results if you didn't set this seed. Then we'll import the matplot library to plot some of the graphs. And of course, import pandas. We run the first one. And now because we need to import the data into the data set, so I want to know what is my working directory, so I can print out my working directory and to see if my data sets have been saved in the same directory. So this is my directory, and my data sets is saved under this Pi data book second edition. So I can just call this data set. So as we can see here, we use the open function to open the path we defined where we wanna look for the data that we want. So I'm looking for a data set. This is my folder. My subfolder is Bytely US government, and I'm looking for this example.txt data. And if you look at the book, it is a JSON file. So when I said open the path, I want to read lines. So it gives me this. This is the typical JSON format. Yeah, it's kind of mess. So what we're going to do is we're going to convert this JSON format into a tablet format, like a normal table. So we can do a bunch of calculations and the visualization. So we import JSON, and then we're going to use this function called loads lines, and we have a for loop. So basically, we're open this path, and we're going to read each line one by one, because this JSON file, they have a lot of lines. So when we run this, and we save these all the lines into this object called records. Run this, then we wanna see how many lines are there, so we can run a length of records. So basically, records is a you can say if it is a list or Here we can take a look. It's a list. So yeah, it has 3,560 elements. Each element, then we want to look at each element. So here we can see, I want to see the element, the last element. So this is the last element. We can see that in this element, we have lots of information. You can see this is a one line from the JSON file, and this is just for one record. And in the JSON file, they usually have this header, A, header C, and they're all separated by this comma. And if you want to look at a different line, you can see, yeah, then a different element contains different information. And if in each element we can call, like, all these different headers. Say we want to see this time zone. You can see here in this one we don't have this. We have this time zone, so we want to look at this specific information here. So we can say, oh, I want to see the records 0, and I want to see what is the time zone. Yeah, then you can see it's America, New York.
So in this, you just show
Yes. Yeah, you're right. So in each in a list, each element stores a dictionary. Yeah. And now since it is in an element, then we can easily use the for loop to actually, let's say we're interested in the time zone information of all these like 3,560 records. So we want to retrieve the time zone information from all the lines. So we can use a for loop. This is what we intend to do. So first of all, this time we gave the name as time zone, and then we run a for loop in this element, and then we'll retrieve all the time zone information that's from this. Give us error. Do you guys have any idea why we have errors in this? Yeah, so the key error, TZ. Any guess why we wrong? Because when we look at this for loop, it looks fine, right? Because basically we're looping through each element, and then we'll retrieve all the element contains this TZ, but it gives us error. Exactly. Yeah, absolutely. Yeah, because that's why if we're calling those TZ, but if some of those lines they don't have TZ, then it returns nothing, and it'll give us the error. And the for loop basically broke. So here we change this line a little bit. So we same loop for rec in records, and then we have a if statement. If TZ is in this rec, which means if there's a TZ in that line, then we'll retrieve the TZ information. Otherwise, we'll continue. So if we run this, yeah, no error. And then we can look at the time zone. We can look at the first 10 lines. You can see, yeah, some of them are America, New York, and also, even though they have the header TZ, but some of the information there is nothing there. It is just there's no time information there. Okay, and since right now we didn't use any of the advanced libraries such as pandas, so we wanna do the count. So we wanna know how many unique time zones in our data set. So what we can do is we can define a get count function, and since we have all the time zones, we have all the records, so we can define a function, basically run a for loop. So in this sequence, if we find a time zone value in that sequence, then we can just do a summation of how many of the same time zone we have encountered in that list. So we define this function, and the same thing we can define a different function. We use this default dict, which is you can initialize the series or this list we were trying to do. So in this case, if we initialize them to 0, then we don't have to run this if else statement anymore. But yeah, this is very simple count function. If you want to know more about what is default dict, you can run this help function. But like you have to import this function first, then you can then you can use the help function. Otherwise, it'll say, oh, we couldn't find this function. Now we can do our count. So we use the first function to count how many time zones. Like we have 1,251 records. They have the same time zone as the American New York. And then we can look at all of them. You can see that, yeah, different time zones, they kind of have a unique number of basically how many they have shown up in our data set. You can also see that there are some empty values, but since it is a string, so it also, yeah, also has, we have 521 records have 0 information about their time zones. Same thing with this, without using the advanced libraries, we can also define a function to give us the top 10 or top 100, basically the most frequent time zones in our records. So we can define this function top counts. We do a for loop to look through like the count in our base. So this is our count. Oh, yeah, this is a function. So in the function, we look through all the elements in this count dict. Then we'll do a sorting function. Then we'll return because the sorting by default is ascending. So we want to get the top 10, we'll do the backwards. And if you want to know what does the count items, we can take a look. So count item is basically a dictionary. So in this tuple. In this tuple, you can see that it's kind of complicated, but like it's items, but like it's a tuple for each record for each of the time zone. So in this tuple, you have the information. The first element of this tuple is this time zone. The second contains the count. Then you can look through this to basically you get the information of the value of this count. Then you do a sort. You run this function. The return. See here, you return a list, but in the list, each element is a tuple. Also, you can import some of the functions already defined. Yeah, it'll be much easier. Yeah, there are a lot of functions that do the same thing. Just depends on what you're looking for. Usually, if you're trying to do any sorting, count, or ranking, like you can't remember every function. Just Google, like much easier. Now we can also use the pandas to do the same task, but with much simpler code, and yeah, it's much easier. And we have learned pandas, I think, several weeks ago, and in that lecture, we've learned how we can deal with the tabular data with pandas, and what is data frame, and we've done the filtering, group by, and some other advanced calculations by using pandas. It's a very powerful package. So we import pandas, and then we make a data frame from our records. As you can see, the data frame, this frame is basically all the records. By running this info, we can get the information about this frame. We can see it's a data frame object, and it contains yeah, so it has a lot, like the data columns. You have different columns, and if you want to see my my frame, or you can each column name, and by each column name you can get the first 10 rows. But we can also use the head if you want to get more. I kind of want to take a peek of this. So as you can see, you have different column names, and yeah, the time zone. Have all this information here. Now we in pandas we have this function called value counts, which will calculate this, like, because in each records you have one row is one record, then it'll automatically calculate how many times this record have shown in this data set.
So this value is for series.
No, it's for the it's so here it kind of give this retrieve this column, and this column becomes a series.
So just in the case, if we want to use value for database, so there are multiple. Does that still work?
I think it'll still work. We can try. You can use apply function. Use apply. I'm not quite sure. Maybe it will not work. No, give us error. Yeah, this is returns a series.
So if you delete that,
oh, let's see. Probably will give us error because if you're counting all the because if you have different columns, if you do the value count, will give you a different result, right? For example, in this time zone, you might have a let's say 100 unique time zones, but in this T, you might have 4,000 unique values. It'll be different row numbers.
I was thinking maybe it requires this row exactly the same as another row, all of them to be the same, but I want so
yeah, doesn't work that way. I think it'd be series, but you can also do it probably followed
or just
group by, yeah, be much, because yeah, this doesn't make sense. You want to do those in multiple columns, but then you have to return different series or tables in your return because they have different row numbers. You can see this TZ count. Yeah, this TZ count is a I think this is a series, and then these are the index, and these are the value. I think it returns a series. Let's take a look. So it's a series. So when you return a series. But you can get a function to return like a list. Each list will have a different length. Well, we contain series, but they have different lengths. Use apply or apply pandas series value count. Let's try this. Yeah. Or can just get several. You guys remember how to select multiple columns?
It's a bracket.
Oh, two list?
Yeah, two lists inside the list.
Like this?
Yeah.
Maybe. Maybe city? Yeah, see why. Yeah. Time zone. Yeah, I think so you have time zone, this empty value have 521. I think it worked. Yeah. So it'll, yeah. City. Okay. Yeah. Now we'll use this fill NA value, a function in to fill in those NAs, but is missing. And we also have found they use a empty string. So the empty string and NA, they're different. NA, which means there's no TZ column, but in some of those TZ column they have this empty string. So we'll kind of replace them with different thing. Now you can see we have unknown, we'll have 521, and then missing we have 120 records. They don't have any information about their time zone. Okay, continue. See, this time zone counts is a series, and these are the index, and the values are these numbers are the values. And now we can start plot this this time zone count that we just created. We import Seaborn to do the plot. So you can see here, this is a bar chart. On the y-axis, use the series index. The x-axis is the values. And then, as we can see, if you go back to our the original data. On the column A, you can see that they have a lot of information there. They have the different browser name, there's a browser, and have the operating system. It's a string, but this string contains multiple information, so we can do a string split to split them into different information. So we can do that in this series. So here we define a function. Oh, we use this pandas series x split. We use a for loop. So frame we select this column A. Column A becomes a series, and then we do a for loop. Yeah, and then we dot split function by default is split by, I think it's space. Oh, yeah, by space. So it'll split you can see here we have the here's a space and there's space, so it'll split by space. We run this, we can take a look. So yeah, so it'll retrieve after it, by default it'll split the whole string with as many as different elements as long as you have spaces. So for example, for this line, it'll split into 1, 2, 3, 4. So it'll retrieve the first element will be this one. Same thing here, it'll get 1, 2, 3, 4. But we're only interested in the first one, so we'll have a element 0 here. And then we do a value count. So we can see that a lot of them, Mozilla, there are 2,500-ish records. Of course, if you're interested in other information, you can use a different element after the split. Drop NA. Yeah, these are just some detailed examples. Here, for this one, when we did a split, it becomes a list. So we have first element, second, yeah, it becomes a list. So by default is split by the space, but you can split by anything else. So maybe back the slash. And here you can see that we're split those by the slash. Keep going. So we'll define a safe frame, which is we retrieve this frame when the A column when there's no null value. This is a typical subsetting method in a data frame. You can take a look at this safe frame. Has all the columns, but right now we don't have NA values anymore. Make a copy. Now we use a NumPy to find, like in this string. So what we're trying to do is in this column A, we want to looking for if in this whole string, if there's any words that is Windows. So we'll do a search. So string, it contains Windows. And if it contains Windows, then we'll give this column value as Windows. If there's no Windows one in that string, then we'll give a not Windows in this new column. So this is operating system OS is a new column that we created based on this logic. As you can see that they're either Windows or not Windows. And this is a new column. Then we'll use the group by from the pandas library. So group by time zone and operation system. And if you want to look at the size, so the size will have similar, will be very similar to the count. So it'll group by time zone. So here you can see the empty or empty string. It has two categories, not Windows, and then the time zone of the Africa. It only has Windows. So same here, Pacific Honolulu. We have Windows, but the Pacific and Auckland, you have two categories, not Windows and Windows. And then we can use this. This is a group by object. So, this size, we can pass this information to the data frame to create a new object. You can run this. Take a look. So here we use the data frame function to convert the information we've seen here into a data frame object. So now you have a two columns. One is or maybe I think those are the indexes. So you have two different level of index, and these are the values. So if we look at the index, you can see it's kind of multi-levels. You have the time zone as the level 1 index, and you also have the not Windows of Windows as a second level of index. Now we can use the onStack function to do a reshape. So we wanna transform this size data frame. So it looks like this. Then we will use the onStack to do a transformation. So here we can see it is a factor, right? Not Windows and Windows. Now we use this onStack. Those become a two different columns if you compare with here. So still have this operating system, but now it becomes two separate columns, and you still have this time zone as your index. We can take a look of here the accounts. You can see the info. It is a data frame, and the index now becomes your time zone is the only index here. And we can look at the columns. The Windows and not Windows becomes your two columns. So by using the onStack, you can you can transform some of your factored index into columns. Now we can call this column. We'll look at, you can see all these this index. These are the values. Now we can use this sort. Use a sort. We can use a sort, the arc sort function, to sort those values. And by default, it's ascending. So what we did here is we did the sum calculation. So I think sum 1 is to sum. Let's get. I think sum 1 is sum row wise. Yeah. Basically, like I want to know the total number of that particular time zone.
What's this number?
This one?
Yes, it was 24, 20.
Yeah, let's take a look. So this is our counts, right? So sum 1 is, I believe it's sum this row and this, so this number plus this number. Yeah, we can double check. So Africa, Cairo. Well, because we have this Africa and Cairo. 97.
I don't know what's the average.
Let's look at this one by one. No, it's 3.
Cairo had more road, not only one.
Yeah.
And others, I think, grew by all the Cairos downtown. Let's see.
But it has, it should contain all the African Cairo. Because we already did a group by.
Oh, already.
Already done that. Oh, is it the ranking? So this ranked at the 20th?
But the empty string should be ranked second. But why is it?
Yeah. And in the book, it didn't mention anything. Returns the indices. Oh, so underlying data. Indices that sort underlying data. Maybe we can look at a simple example. So this is index. Series 34. So it returns the index, not the number.
The index should be 0, 1, 2, 3.
Yeah.
Why?
Yeah. Totally 97.
Yeah.
97. I think ugly count also 97. Ugly count 97. After ugly sort 0 97. Maybe
I think it looks at the index.
index
Index from which?
And it's the integer, right? So those are the index for.
ugly count. Ugly count.
Okay, let's see. What is the
you can print all the ugly count.
index? Oh.
I think you don't have.
Well, these are the index.
So it said underlying. Oh, it's not based on the values, like the values in that. So, which is the lowest number, but they will list the index of the lowest number. So for example, if we have a list of 1, 2, 3, 0, it will list as 3, 0, 1, 2, 3, 0, 1, 2. Like if we return to 1.
Yeah.
Very light.
Oh, I have better things.
Okay. So if we have a list of numbers that this is a list. If they use our like this index is 0, 1, 2, 3. So it will return a list as like lowest of values goes to first, which is 2, 3, 1, 0. Yeah.
Yeah, I think that makes sense.
But in that case, sorry, in that case, empty string should be 2 because it's the second highest. The empty string, the 521, because it should be the highest. It's second highest. The highest is the American New York. American New York is 1,000.
Yeah, we can go back.
Yeah, this is not easy.
Maybe that one rank 25. Then we can.
Okay, can try sort it instead of sort. Just sort it. And the bracket, try maybe I'm not sure.
It should be. What is my?
Yeah, see, this is another thing. Or reset index. After the first one, go up.
There?
No. Go up. The up.
Oh, this one.
Yeah. Dot. Reset. No, after the bracket. Dot reset. Underscore. Analog and index. Bracket. 0.
Oh, okay.
I think you should use sort dash. Sorry, underline values. Sort.
Yeah, så kan man start. You need start a series.
Yeah, so 0.
I think you need to.
Oh, yeah.
Series 7. Can you just use use sort values, not sort.
Underscore?
Yeah, values. But by inside bracket by. Oh, by equal to. Yeah. 0. The string 0. And I said we can get rid of this. You need a square bracket around the. So make it square bracket.
Why Python is so complicated? I can easily do this in R. Key error. Let's see.
There are 2 columns, TZ and 0.
Can we give the new name?
Yeah, we can.
Okay. So this is.
Yeah. So that entity should be 2. No, that should be 1. The entity string. Well, we already have an index.
This is 0.
This is 0 because from your reset index,
Mm.
you put 0 for the empty string.
Mm. Let's see here. Yeah, we can take it offline. I think it returns the index for sure, but
These two numbers are same as the index you get. The first several index is the same number. But index number this thing is the same as that you created re-index the one. But the name is different.
yeah. Well, like what it does is it kind of what it's trying to do is trying to get the first 10. Well, kind of give store this index into this indexer, and what it's trying to do is to, I think they're gonna use the indexer later.
Re-index
Yeah, they say here they use the take function to take that indexer. Then it'll become take that indexer. So the index looks like this. And then we use a take function. Now we can see the new index of this one. If we take a look. Pretty sure they have changed the index. Once we run that.
So this index is the original data frame index. After you take the index, they change the order.
Yeah, I think you're right. Yeah, based on the number, they use that arcsort and then use that ranking or.
So they based on the ranking of the two columns.
They're based on the ranking of the total. There's sum of the windows and not windows. Yeah, then just they use the new order. Now if we take a look of this, so now you just use the last 10. If we take a look, then you only give us the last 10 rows. So use the last 10 index value from the indexer. Yeah. So I think the last 10, they have the from the smallest to the biggest. So the last 10, you can see this has the largest numbers here, and then the second one is this one, right? Yeah.
The line, so the sum of the bottom row is less than the second row.
Yeah, exactly. Yeah. Yes, basically they just take the order from this indexer, and then you do this subsetting by using this take function. And we can also use the n largest, make it much easier. So if the previous steps are too confusing, we can just use this simple method. Yeah, we can use this, n largest will return automatically the top 10. Now we previously did the unstack, now we can do the stack. So we'll stack the columns back into the indexes. Now you can see we have two levels. First one is the time zone, the second one is the windows or not windows. Now the values become just those count numbers. Same thing still. So the unstack will become a series, right? So it'll be easy to transform between series and data frame by manipulating their index. Now we'll do some plotting, some errors. I probably have done so many index and reset index. Oh. I want to take a look at the oh, my computer's frozen. So my subset looks like this. Indexed OS, Windows. Reset index. Now there are my columns. X. I need to create this new column, I guess.
Total just the name, X name. That's the new
Oh.
column.
Oh, this.
That's the name, not number.
Oh.
X equal total, just X label. Label.
Yeah, it's a name of a column.
Yeah.
So if you go up, I think maybe you miss one.
Yeah, but I want to create a new column by.
I run the previous.
Yeah. Count subset dot name.
Yeah. If you go, what's the count subset right now? You already changed the subset, but here up. If you go up, yes. This moment, you can see this count subset.
So
You just it's reindex and then
Yeah.
that column to be total.
count subset stack index values. Count subset dot name total. But
But why it changes from a series to a data frame?
This just the data from had this name has no meaning. Just when you plot, yeah.
oh, now we have the total. Count subset. So now our count subset looks like this. Oh,
This
this is our total.
this totally you just add it.
Yeah, but it's not.
Not the if you plot it may be different.
Yeah, it's different. So this table is trying to plot. Let's see.
This even just try to plot the two values,
Yeah.
windows and non-windows. The total just a label of the single.
X is total.
Yeah, X the name is total. Y X name is TB.
It's
Yeah.
also the data.
No.
It's from the concept.
Yeah, that's the concept.
And the X is the concept set total column and Y is concept set TZ column. That's the bar plot.
Yeah, it should give us. So we want to plot this value 33, right? This column.
Yeah.
But then we want to use the TZ as our Y, and then we'll use. Maybe it's our. This is wrong.
Yeah, we should
re-index. That should be our. The hue should be a category.
I think if you recruit concept from ugly so very.
I think we overdone. We did several times index, re-index, because this not Windows, they should become the index, not the column. how about we just ask that? Yeah.
Index as an index level.
So here we want to use this one, right?
Yeah.
Like count
At
substance.
this point, we are correct.
Yeah.
But then we
Yeah, this one they are correct. That's add the last column total, the name total.
but
Yeah.
right now your subset already changed.
Yeah, that's why I think it's not recommended to use the same object name
Yeah, again.
again and again.
Go up where? Yeah, right
Uh,
now.
Yeah, I messed up. Let's want to go back. Okay, here.
Yeah, here.
Okay, then we'll do the unstack.
Yes.
Stack.
Yes.
Stack.
Yeah, we'll do a stack. Yeah,
Yeah.
sorry, stack.
The stack and
All right.
give the name total.
Yeah. Yeah, and then we give a name.
Yeah.
The name is this. This column will be named this total. Yeah, yeah. Well, I'm not going wrong this one. Yes. Yeah, you can see the name is total.
Yeah.
And then now we can, I guess we can plot.
You need to be.
But we have to plot this first.
Yeah, but you should leave that.
Oh yeah, this
total
one.
equal
Yeah.
that. Yeah, this one.
And then they'll reset index again, right?
Yeah.
Yeah, yeah.
Okay. Yeah.
Okay,
Yeah.
now
Right.
good.
Yeah.
Now we should be good.
Yeah.
And now we can plot.
Here we go. Teamwork. So lessons learned: never, never like name the same objects several times. Okay, now we'll define this function. We're trying to normalize the values. So we'll take the total number of. We have like different groups, the not windows and windows. Then we'll do a normalization. So what we did is we want to see like the how much percentage of the of this time zone, I guess. You can see all the percentage here. Then we'll do the plotting. Now its plot is the norm total. Yeah. Then we can use the group by. Use the apply function. See, after we're done this group by, will be either labeled as a group by data frame. Look at the sum. They give us the total of each time zone. And the transform, we can use the transform to calculate the, basically it's just get the sum. use this function sum, and then the transform, it will calculate to the counts of different time zones. Yeah, same thing here. Okay, then we will move to the next example. This is the movie reviews. So this data set has about 1 million rows. It contains different movie names and also the online reviews based on different gender. So this data is called this movie. So it has three different data sets and contains the movies.dat and ratings.dat and also the user information. So the DAT files, they're very common in those large data sets. So to open them, we'll use this rate table from pandas. So we'll rate these three data sets by using the rate table function. Now they're already rating. We can look at the what information is in each data set. So look at the first 5 rows of the users. Still running. So the users, you can see that they have 5 columns. Have the user ID, gender, age, occupation, and their zip code. Same thing with the ratings. So ratings has the user ID, movie ID, rating, and timestamp. And then movies has the movie ID, title, and genres. So here we can introduce this this new function called string.split. So in the genres, we can see one movie they can belong to different categories. So, but it is separated by this symbol here. So we can do a string split to split them in. So one movie can belong to more than one categories. And what we're trying to do is we're trying to separate the different genres, and then we'll contain the information in the same data frame. So what we can do is we can use this function called string split by the symbol here. You can see here they're being split into different lists, and then what we want to do is we want to do a we want to kind of make this list. This is in each genre that has a list, but we want to have separate this list into multiple rows. That's essentially what we're trying to do. So we'll first of all make a list, and then we use the movie's title as the index. Then we'll do a stack. So now you can see like one movie. This is the index. Then it has 3 rows. So this one movie will have different genres: animation, children's, comedy, and they've already been separated, and we've taken this list format and take each element from that list to form one row, essentially.
So if you don't use two lists,
Mm.
what will happen?
If we don't use, we can see, we can take a look. It's empty. So because this is a string, so here you take this genres, right? This is a series. And then you use this string split.
Become another series.
Yeah, become another. Well, maybe this will be probably the list. So here will look like this, right? So movies, genres. If you do the split, it will be a
Series.
yeah, the series. Then you will make this series into a list. And then you give this new, so basically you make a new data frame, but by taking this series, but this series has to be made into a list first, right? And then you make a new data frame. And then you give this data from the index as this movies, the title as the index. Then you do a stack.
So I think the use of these two lists is get rid of the index of your series.
This one, yeah, yeah. It's making a list, and then yeah, you're right. Okay. So now I can, what I want to do is so this is my data frame B contains, I wanna have separate rows for each category. So what I did is a kind of reset index and then give this kind of give the title. So what I did is reset index, and then I gave the so here there's no title for this, my genre column. Oh, sorry. So my genre column name is, after this transformation is by default 0. And I raise the index as I want to make my title, my index into a new column. So now my title have been repeated 3 times. It has 3 genres. Then I can merge my new data frame with my movies. So here I change the column names into the genre split and title. Then I merge my B data frame with my original movies, and I want to do a left join. So I keep all the information in my B, adding new columns for my movies. Now now my movie is new. I'll have my title, my movie ID, and my original genres, which is this, and also my splitted genres. So in this way, we can select one movie. They'll have different categories. Then, yeah. Of course, it'll be yes bigger. It'll become bigger data set because you have repeated rows. Okay. Now what we were trying to do is trying to use this merge function to merge. First of all, we merge this rating table with the users, and then after, so by default is inner merge. So it'll find all the matched key columns, and then after we merge this one, we'll merge with the movies. The data, you can see the first row. We have user ID, movie ID, rating, timestamp, gender. We have all, basically now we have all the different information in different columns. Now we use the pivot function to make this table to pivot this table, and then we will, by choosing what index we want and the columns, also will give them a aggregation function. I can explain how. So here we choose these columns with as a gender. So the gender has female or male, and then we choose the index, the title. So the title is our index. Then the rating is actually the number we're trying to apply this calculation. So the rating have different values. So for each movie, what we're trying to do, we're trying to, for all the female ratings, we'll do a average calculation of the female ratings, and also we'll do the same thing. We'll have the average calculation for the ratings from the males for each movie. That's basically what this pivoting is doing. Same thing here. We'll rating by title. This is our mean ratings called this one, and rating by title. Yeah, we can run this. Rating by title. So what it's trying to do is to group by title, and then the size we have introduced previously, and we'll choose the so either count, or for the same movie you have different number of people who did the reviews. We're only interested in if we have more than 250 reviews. It's basically what it does. And the size will give you kind of a unique count for each movie. Then we can use the active titles to get our subsetted data frame. Now we have much smaller rows. Then you can rename, because some of the movies they have different name. You can do this by using rename. Give them different names. Those are the typical pandas functions. And top female, same thing here. You can mean ratings sort value by yeah, this is the one, yeah, you mentioned previously. By this is the female or male. Then by default, ascending is true, but here we want to see the descending. So now you can see that, yeah, all these ratings, female and male, and they're in a descending order. So the highest 4.6 for female, for male is 4.47. But we only choose the female is descending, so it's from 4.6 or the 4.5. But the male is still by default, it should be the, so we didn't do any of the sorting on the male side. That's why there's no order on the male side. We can do a calculation. We can create a new column, do this calculation. We want to see the difference between the male's review and the female's review. Then we can do a sort. We want to see the most, like, what are those movies that have the, you know, the largest difference between two genders. Same thing, we can do the use the group by and do a standard deviation. You know, what we're group by title, and then we're do this. We want to calculate the standard deviation on the column rating. So, yeah. Then you can find, you know, people will have different opinions on some movies. Some movie maybe will have more different opinions than others. That's the standard deviation can tell you that information. So the last example, I'll go this very quickly, is in the US baby names. Here, the data structure is different because if you go to the folder, go to the baby's name, it contains like maybe 50 text files, but all these text files have similar names, but they just vary with different years. So we can use a function or use a for loop to read through all the file names. This is just some example of how we can take a look of the data set. So they all have the same column names and the same file names. Yeah, and then we can loop through. So it defines a path. So they all have the same path data sets, baby names, and they all have the first three file name the same, year of birth, and then use this symbol to kind of represent because we're going to loop through the year. And from the files name, we see the year is from 1880 to 2011. So we'll do this looping and then combine all these different files into one data frame. Names. So you can see we have 1.7 millions of rows, and they all have the same column names. So it's basically what names, you know, how many times of these different names have been used in different years. We can get a plot. So we'll use we'll plot the we want to see like in each year how many newborns are there in each year by different gender. So female and male, you can see a trend there, have more and more new babies. So we just want to take a look of in this whole data set, what are our populations? Define function, we want to calculate a proportion. So the so you have female and male, have different genders. So we just want to say the, you know, in that particular year, what is the percentage of female or male? Now you can see that, you know, like to check this, we can see we want to sum the prop. So you have female, male. So the summation of the proportion will be 1. So looks like they're all 1. But in the data set, the percentage, you have the male, we have some percentage. The male have different percentage. Oh yeah, yeah. Year sex.
So for 1 year, 1 gender.
Oh yeah, yeah, you're right. Yeah, birth. Book of birth. Yeah, name. Year and sex. Yeah, I want to see this name in terms of frequency, like percentage, how often it has been used. Now we want to, you know, define a function to get my top 1,000 names that have been used. Because this data is so big, so we want to drop the rest. Basically, make a new data set. Yeah, now you have much smaller, much smaller data set to work with. Here we'll do the same thing. We want to make subsetting based on the gender, boys and girls. And here we will use this pivot table function again, that we showed before. Now we want to plot you know, we want to plot like those 3 names, which only choose John, Harry, Mary, and Marilyn to see their you know, popularity at different years. And this one is to show like the, you know, like for my top 1,000 name, what's the proportion of my top 1,000 name in each year. It's been changing because usually, you know, in the very beginning, my top 1,000 name will be used by most of them. But as the year goes by, the proportion of my top 1,000 name has been changed. So which means we have more diversity in terms of names. Now we subsetting for 2010. You can see what those names are for the boys. Then we'll do the cum sum. So the cum sum is very popular because let's say we wanna first we'll sort this my proportion, by descending. So I wanna find how many names have to, like, this one has to be used so that I have 50% of my population will use that name. So this gives the number is 116. This is 2010. But in 1900, 25. So 25 different names will be 50% of my population. But in 2010, there are 116 names, different names. So the diversity is changing. Yeah. So here they're all the same thing. You use group by, and you can define your own function, and then by use this apply. So group by and apply this function to to get the quantile count. So now you want to looking for either is 50% or some other user defined percentages. And then we can plot this diversity table. So you can see that, the diversity is getting, especially from 1980, like the girl's name is more diversified with it than the boy's name. So the last one is, they also want to see the last letter revolution. So basically what it's trying to do is trying to find the last letter of each name and do a statistical analysis on those last letters. So they use this lambda function. So define a lambda function to retrieve the last letter of that string. And now we can see the names. And the names are this one. And then we can see the table, which is should contain the last letter. This is pivoting. So the last letter you have A, B, C, and then the people that female and male on different years. Same thing with the reindex, we choose 3 years, and the level is year. Now you can see see that, like, these 3 different years, female and male, and the last letter. This is how many times they have been used. In the period, have a cum sum there. The subtable can do some calculations. Now we can get this letter proposition. The same thing will, use a subtable divided by the sum. Now you can see this percentage that being used in different years. Now we can plot. So this is a bar chart. So in this plot, it choose, select what kind of plots. The axis, the title will be male and female, and all this is in the subplots data frame. You can see the last letter changes at different years. Yeah. You can also look at the different letters. So D and Y, and you choose the male. This is to look at the male. And then the T, I think it's transform. Yeah. You can see the change, like they're changing at different years. I think that's pretty much everything I've got today. I'll leave the rest to you, Robin. So what we have learned is how we use the reindex and also the group by functions. And we also learned the in the pandas how we use different like cum sum function and how we use the user defined function in the apply. And so yeah, it's kind of like sometimes it's confusing, but if we can use unique name for different objects, it will be less confusing and less error. So yeah, that's everything. Thank you.